Hello, you're welcome back. All right, so we will continue from where we stop. Here we are going to be looking at questions, okay? Problems and solutions. So I have the very first question here. It goes like this: A 90 cm uniform lever has a load of 30 newtons suspended at 15 cm from one of its ends. Okay, so this is end. So we know very well that questions on the principle of moment is basically what problem. So you read the question, then you have to draw the diagram so that you know the position of the clockwise moment and that of the anti-clockwise moment. Okay, so now I have to actually represent everything in that question in the diagram. So the beam is 90 cm, so I gotta draw that. Okay, 90 cm, and the load. Okay, I was also told that a load of 30 newtons is suspended at 15 cm mark. So at 15 cm mark from one end, then I have a load of 30 newton being suspended. All right, so now with what I have here, okay, I can still let me continue with the question. If the fulcrum is at the center of gravity, that simply means that the fulcrum being the pivot is pivoted at the center. So and of course the center of 90 cm is 45 cm. So I'm gonna write 45 cm. Okay, so now the question is, okay, the force that must be applied at each other end to keep it horizontally at equilibrium. Okay, so the force that must apply at this end. I wasn't given a distance, so it is at the extreme. So I don't know what that force is. I call it F. Okay, so now I can apply the principle of moment. This F will create a clockwise moment, while of course the 30 Newton create an anti-clockwise moment. But don't forget that we need to get their distance, the distance of each of the force from the pivot. Okay, so each of these force I need to get their distance from the pivot, and of course from F to 45 is 45 cm. From this end to the center is 45 cm. Already from the end to this point is 15 cm. So what is left is going to be 15 minus 45 minus 15, which of course is 30. So I can now apply the principle of moment, okay, which states that clockwise moment is equal to anti-clockwise moment. Clockwise moment is equal to anti-clockwise moment. So my clockwise moment is going to be equal to F times 45, which is equal to the anti-clockwise moment. That's 30 times 30. Okay, so with what I have here now, F now is going to equal to 30 times 30 is 900. So that's going to be 900 divided by 45. So when you divide 900 by 45, you have 20 cm. Okay, so that is the value of F. As simple as that. All right, so let's actually proceed. Let's look at more questions. Okay, I have another question here. Probably I'll have to take this to the screen. Okay, so let me clean up. Okay, so this goes this way. Let's mark that first. Okay, so here we go. Now the question goes that if fig 1 PT is a uniform rule. Okay, from all indication, the diagram wasn't drawn well. Hmm. Okay, so the diagram wasn't drawn well, so I have to make sure that this. So this is P, from P to T. This Q is this position, and the R is the, okay. The Q is the position where this 0.1 Newton is being placed. R is the point of the pivot. Okay, then of course X is the point where 0.4 Newton is being placed. Okay, so now you can now read the question. So if it one PT is a uniform meter loop pivoted at R, okay, here's our pivot, the 70 cm mark. So R is this, ours is 70 cm mark. R is 70 cm mark. So I can just come to R and just make sure that, okay, so R is 70 cm. So point R 70 cm mark. Two forces 0.1 Newton and 0.4 Newton are, are applied at Q, the 60 cm mark. So Q is 60 cm. Okay, and X, the 85 cm mark. S here is 85 cm mark. All right, so now what are we looking for? 85 cm mark. If the meter rule is kept at equilibrium by the forces and its weight, so we are told that this force here applied at both ends of this pivot and the weight of the meter rule keep this meter rule at equilibrium. All right, okay, by the forces and its weight, then the weight of the meter rule. So of course the diagram have already been drawn well for us, but we're looking for the weight. The question is, where, at what point will I place the weight of this meter rule? Okay, you should know very well that the weight of a meter rule, please, you should know very well that the weight of a meter rule, okay, actually acts at the center of the meter rule. So if I should represent the weight of the meter rule, that should be at 50 cm, because this meter rule is uniform, okay? The uniform meter rule in the laboratory is 100 cm. So invariably, the center of that meter rule is definitely going to be at 50 cm. So, and I'm looking for the weight of the meter rule. So I don't know what it is. I'll represent that with W, okay? All right, so I cannot take moment, okay? Now, before I have to take moment, so know very well that 0.4 Newton at this other end, at point 85, will always give me clockwise moment. Now, there are two anti-clockwise moments, okay? 0.1 Newton goes anti-clockwise because it at the other end of the pivot. Even the weight of the meter rule that I'm looking for also give me anti-clockwise. So what am I going to get now? I need to get their distance, okay? The distance between 0.4 and 70. So the distance from 70 to 85, you know what that should be? That should be 15, right? So distance from this point to this point is 15. And you should know that the distance from 60 to 70, the distance from 0.1 Newton to the pivot, which is at 70 cm, okay? That should be 70 minus 60. So this distance is 10. And the distance all the way from the center, 50 Newton to the pivot, which is at 70 Newton. I know what that should be. That should be 20. Okay? So I cannot take my moment. So let's take our moment. You know what it is? Clockwise moment. Okay? It's equal to the algebraic sum of the anticlockwise moment. Algebraic sum of the clockwise moment is equal to the algebraic sum of the anticlockwise moment. So I have only one clockwise moment, that is 0.4 Newton, okay? So 0.4 Newton multiplied by the distance from the pivot, that is 15, equal to, I have two anticlockwise moments. One is 0.1 Newton, and the distance, which is 10. The other is the weight of the meter rule that I'm looking for, times the distance, which of course is 20. So 0.4 times 15. So what should that should give me 2 Newton, if I'm not mistaken. Okay, is it 2? 4 times of 4 times 5 is 20, 4 times 1 is 4. Okay, plus 1. Plus 1, that's 5 Newton, all right? So you can use calculator to confirm that 0.1 multiplied by 10 is 1. Then plus 20 W. So making 20 W the subject, I'm gonna have, okay, 5 minus 1. Okay, so 20 W is gonna be equal to 4. So W is equal to 4 all over 20. All right, so let's work on that. 4 all over 20. That should be 0.2 Newton. Okay, so that's the weight of the meter rule. Okay, another question. Let me maximize this. Okay, here we go. This goes this way. A meter rule is pivoted at its midpoint. So I need to draw the diagram of this one. Okay, it's a word problem. So this meter rule is pivoted at the midpoint, though we are not told where the midpoint is. Okay, but let me just pivot the meter rule at the midpoint. Okay, pivoted at the midpoint with a force of 10 Newton hanging from hanging 10 with a force of 10 Newton hanging from the distance of 30 cm from the midpoint. Okay, so a distance of 30 cm from this midpoint. So we have a force of 10 Newton. So what are we looking for? At what distance must a 15 Newton force, okay, force be hung to balance the ruler horizontally? So probably at what distance from the same midpoint? At what distance from the midpoint? And that should be at the other side, okay? It won't be at this side. If I want to balance the meter, I have to hang the another force, the force of 15 Newton at the other side. Okay, wait, what's the question? At what distance we what? Okay, at what distance with the force? So we don't know the distance. So I just, the distance from the pivot, I don't know what it is. I call it X. And that force is a force of 15 Newton. Simple. Clockwise moment and anti-clockwise moment. Okay? Clockwise moment is 15 times X. 15X is equal to the anti-clockwise moment, which is 10 times 30. So S is going to be equal to now 10 times 30, that's 300 divided by 15. So that's 20 cm. As simple as that. All right, let's look at, okay, that is basically what we have. If there are more questions, I will actually introduce that in the next video. All right, see you in the next video. Thank you very much.